Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Today's screencast, like most of my screencasts, will be about the reciprocal system, specifically the reciprocal system Microcosmos database, which you can see on the left panel here. I've already covered all the layouts in previous screencasts for the reciprocal system Macrocosmos database. Last week, I covered liquid vapor gas matter properties, energy, and entropy. So this week I'm going to go with viscosity and surface tension. So clicking there, and here's the screen. As usual, in the first field we have the element or the compound or the mix, which we've been using H2O for our sample record. Description is ice, water, and steam, obviously. Form number 1, atomic molecular weight is here. Observed melting temperature in Kelvin is here. Vapor gas symbol is here. Now this is the same, but in some gases, for example, it's different. And atomic molecular weight here again. Delta V is 0 for this particular compound. It might be different. Please see my paper on the theory of liquids, vapors, and gases in Existence Interactions, a computational treatise of the reciprocal system, the true theory of everything, for a description of all the fields and the equations behind this whole system here. All right, I'm going to go, let's go back. Now, this whole row here is the same as for previous screens, except for N sub T for surface tension, N sub T for viscosity. But what I want to do is just go back to specific heat, so I can just read the tooltips for you there. So we're in this layout, specific heat. We just jumped there from viscosity, but I just want to go over this top row. This is key. These are structural parameters. They're not regression coefficients or anything like that like other theories. These are actual structural parameters in the theory. So I just want to make sure that everybody understands these as well as possible. But you really should read the paper. Alright, so this is the number of atoms, which is easy, it's 2. Number of elements, which is 2. Number of atoms, which is 3. And then here we have the number of close packed groups per molecule in the solid state, the number of close packed groups per molecule in the liquid state, the number of initial units and extrapolated back to 0K for specific heat of the liquid. This is the number of structural groups having internal motion, number of liquid thermal groups per molecule, 1.5 there. Number of liquid structural groups per molecule, 1.5. And then we have the number of liquid volumetric units, the number of liquid temperature units, and number of units resisting external pressure. Okay, so now let's go jump back to viscosity here. And this is usually the same as NT, but it doesn't have to be. So in this case, it's 2.5 versus 2. And the NT for viscosity is 2.25. It could be the same as the regular NT. So you can see it's close, but not exactly. So it can vary a little bit depending on what property we're using. And N sub P is the same, it's 9. Alright, so here's, if you see these in the blocks, these are things that you can enter. So you can put in the temperature, in this case 600 K, and the external pressure in atmospheres, 500 atmospheres. So here we calculate the critical temperature calculated versus observed. Again, it's pretty close. Critical pressure in atmospheres calculated versus observed. You have the choice of using the vapor pressure as external pressure. It's no, because we're going to enter in 500 atmospheres here. So with this, the question is, what is the surface tension? Surface tension is measured in dynes per centimeter. So we have the calculated and observed values. Calculated, observed. Now, we can compare the calculated theoretical values to the Yaws regression coefficients. Carl Yaws wrote this very important book, Chemical Properties Handbook, which has all the regression equations for numerous compounds and elements. Very, very important work, and that's what we use to compare the theory to the observed data, to the observed data, but actually is expressed in regression, so it's not like comparing point by point. So anyway, in the Yaws regression equation, there's coefficient A and there's the value of n. So here's the viscosity, CP, calculated, and that's observed. And fluidity is just the inverse, CP inverse, calculated, observed. And now Yaws needs, look at this, 4 parameters here, plus he needs to use, well, here's the surface tension, that's 2. But then for the viscosity, he needs 4 regression coefficients. So, you know, that's the difference right there. This is, well, neither conventional theory nor the reciprocal system has method mechanical solubility. So we don't, there's no solubility stuff here, but there could be for other molecules, okay? Here's the diffusion coefficient through water, centimeters squared per second, is empirical. But he doesn't have the values there either. All right, so this takes care of the liquid part. So again, we have the surface tension calculated here versus observed, and based on the regression coefficient. And then we have the viscosity versus observed. And that's the Yaws value right there. Okay. All right. And then we go on the vapor and real ideal gas. So in this case, there's no, in the previous properties, we separate the vapor versus the real or ideal gas. These values come over from the other screen, so I'm not going to read them again. But anyway, you can put in the temperature K. In this case, I put in 646.65. The viscosity regression equation for the vapor or gas, these are the Yaws regression coefficients, 3 in this case. And I put in input 601 atmospheres for the pressure. So viscosity in mu pascals versus observed. That's the Yaws value, pretty close. Fluidity is the inverse of viscosity, of course, so there you go there. And then the diffusion coefficient is this, and it's based on empirical values. All right, so I do have some other values here. Here's like temperature of the liquid, pressure. Of course, all temperatures are in Kelvin, absolute degrees. Pressure in atmospheres, and then vapor, and then real gas. And then based on these values here, we calculate the speed of sound. So calculated versus observed, calculated versus observed, calculated versus observed. I'm sorry, this would be, let's see. Now this is calculated vapor, calculated ideal vapor, and then for real gas and ideal gas. Compressibility factors, so on. And here I just have a couple places where you can put in enthalpy of combustion. That's only for hydrocarbons. Obviously, there's no enthalpy of combustion for water. And enthalpy of formation, hydrocarbons only. And Yaws has his own regression equations there. All right, there's a lot of material here. The speed of sound calculation. Now, this is a little bit off between the calculation and the observed value, so that's kind of interesting. But you can see this is, you know, pretty unusual. 600, you know, for the liquid, 600K and 500 atmospheres. Now here, these are all calculated values, of course. If we're just treating this as an ideal gas, it's 808, but the real gas reciprocal system calculation is 700. So you can see you really have to use, the ideal gas equations just don't work very well. Speed of sound when you're considering, something like 850 K in temperature and 500 atmospheres. All right. Well, anyway, that wraps it up for today. Please study the reciprocal system and prove it for yourself. The simplest possible treatment is My Mysterious Universe. The Mysterious Universe, published many years ago, still in print, has all the concepts, many, many diagrams, very nicely organized. So it's the simplest, easiest way to understand the theory, but without the mathematics. But if you do want all the mathematics, please obtain my work, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDF file, 711 slides in the PowerPoint file. Thousands and thousands of equations, diagrams, tables, figures, everything. It'll take you months to go through it. And then once you've done that, then you can come to these two database modules. Microcosmos database. I discussed viscosity and surface tension today under liquid vapor gas matter properties. The Microcosmos database covers solid matter properties, including anatomic distance, valence, specific heat, energy and entropy, thermal expansion, compressibility, electrical and magnetic properties, isotopes, and atomic spectra. It covers liquid vapor gas matter properties, volume and density, specific heat, energy and entropy, viscosity, and surface tension, which is what we covered today, electrical and thermal conductivity. Also covers cosmic elements and subatomic particles, including material and cosmic subatomic particles, and of course, photon properties. And it includes a great graphing package. Then for the Macrocosmos database, this covers the universe as a whole, galaxy clusters and groups, galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, gas and dust, and voids. Thence, if you want to just jump to the section which has all the pictures and videos. This also includes a great graphics program. Now, my theoretical physics mentor, Doobie Larson, was also a theoretical economist, and I've made his work in economics also fully computational. This is my work called Optimal Economist and Implementation of Larsonian Econophysics. It covers the microeconomics of individuals, businesses, and business sectors. It also covers the macroeconomics of entire countries and regions. Completely supersedes Keynesian economics. Like I said, it's fully computational. There's nothing like this in all the world. And just a few months ago, I drastically reduced all the prices. Each database module is $95 only, and Optimal Economist is also only $95. Existence and Interactions is still $33, and the Mysterious Universe is still $9.50. All very reasonably priced, and we provide lifetime free support for any of our work here. All right, that wraps it up for today. Again, please study the reciprocal system and prove it for yourself. And thanks for your attention.